Hello everyone, and welcome to your video that is going to discuss dividing polynomials by one term. So let's say we have a polynomial that looks like this, 15x minus 20. And for whatever reason, we want to divide this by 5. How are we going to do that? Well, what we're going to do is we're going to rewrite the equation so that we can show that each term is being divided by 5. One mistake that students often make is they'll divide the 15x by the 5, but then they'll just leave the negative 20 there, which is no good. The negative 20 also has to be divided by 5. And then once you get to this point, then it's reducing your fractions. This becomes a 3. So we're left with a 3x here, right, because we didn't change the x. And this becomes a 4. So 3x minus 4 is what we get when we take 15x minus 20 and we divide it by 5. Here's another way that you might want to think about this. 3x minus 4 times 5 gives us 15x minus 20. That's another way for you to kind of visualize what's happening here. We took 15x minus 20 and divided it by 5 to get the 3x minus 4. To work backwards, you could take the 3x minus 4, multiply it by 5, and you'd be right back to where you started. All right, let's do another one. A nice, easy one because, we're just starting out. So let's say that we took 40x to the third minus 20x. And we're going to divide that by 10x. What are we going to get? Well, this is going to become 40x to the third over 10x minus 20x over 10x. Now that we've done that, hopefully you can see what gets to be crossed off. Look here at your x's. This is really x times x times x, right? That's x to the third. And here is an x. Two of these, well, this one and this one can cancel out, but that still leaves us with an x squared up on top. X squared. 40 divided by 10 is 4. So when we reduce this, we wind up with 4x squared. Over here, our x's cancel out, and our numbers reduce to 2. So we get 4x squared minus 2. Now, you might have noticed that the first time we did a problem, I had us just dividing by 5. This second problem, I had us dividing by 10x. That's still considered one term. As long as your items down here are being multiplied together and not added, we can still count it as just one term. So let's say I had this. Let's say I had 25x to the third, y to the fifth, m to the 20th, plus, 45 x y to the 9th, m to the 10th, and I divide it all by 5x to the 9th, y to the 2nd, m to the 100. This is still considered one term. I don't have to do anything funky. So even though it's long and it includes a lot of variables, every one of these things is being multiplied together, so it's considered one term. We have 2 terms in the numerator. We have 1 term in the denominator. Now, just for fun, let's do this problem. So this would be 25x to the third, y to the fifth, m to the 20th over 5x to the 9th, y squared, m to the 100th. And over here we have 45x, y to the 9th, m to the 10th over 5x to the 9th, y squared, m to the 100th. All right, let's see what we can do. Oh, by the way, I know that some of you are going to try to skip this step. You're not going to want to write it out. You're just going to try to do it all in your head. That's totally fine. As long as you get the problem right, that's great. I find that the more complicated my terms get, even if there's only 2 terms, the more complicated they get, the more likely I am to make a mistake. That's why I write it out. But sometimes, if you're feeling up to it, if you're well caffeinated, then go ahead and try to do it in your head. All right, so here, let's see. I'm going to deal with my m's first, and I'm going to have an 80 in the bottom, right? Because I have 100 in the denominator, and I have only 20 in the numerator, so that'll leave me 80 in the bottom. My y's, I'll have y to the 3rd on the top. My x's, I'll have an x to the 6th on the bottom. Yep, that looks right. And then this will become a 5. So my term now is 5 y to the 3rd over x to the 6th m to the 80th. All right? And then over here, that becomes a 9. This becomes an x to the 8th. This becomes a y to the 7th. And that becomes an m to the 90th. So, making that all look pretty now, I get 9y to the 7th over x to the 8th, m to the 90th. All right, big numbers and a lot of them, but totally correct.